The question right now is on lesson 17, number 4, if you also needed help with that one right now. So at the end of each year, 10% interest is charged on a $500 loan. The interest applies to any unpaid balance on the loan, including previous interest. Select all the expressions that represent the loan balance after 2 years, if no payments are made. So we have percents involved, so first step that I would do is write down my reference equation. We want to know what the unpaid balance is, so I can leave the Y as my unknown, because we don't know what that is yet. What's my A going to be? Table 2, can you tell me? 500, my initial amount is 500. Does interest add or subtract to the cost? So it'll be 1 plus my percentage rate as a decimal. So table 3 with my percentage rate as a decimal. Good. Or 0.10, same difference. And then my T would be the time frame. And now that we've kind of added different types of problems in there, just make sure you go back and reread to make sure you know how T is being expressed. So it says at the end of each year, this 10% interest is applied. So if we want to know for after 2 years, what should my value of T be? Table 4. Okay, good. If it was like a monthly interest, then after 2 years, that would be 24 months or whatever. So you just have to go back and read how many times are they applying that interest. So in 2 years, they'd apply it twice. So one of them that matches would definitely be the one that looks most like ours. The only difference is they added the 0.10 to make it this. What's another easy variation to see? Like table 6, what do exponents tell us to do?
How many times do you play?
So how many times to multiply our base? So if our base is 1.1 and it's to the power of 2, that can also be written as this. So I would pick this one. And now let's see if there's any other like funky ways that are also equivalent. If they are equivalent, they should give us the same answer. Like if I did calculate this and then I calculated the other ones that are less obvious. But let's see. I don't know why you would add 500. So I'm not gonna go with the first one. Down here again, I'm not gonna add 500. That's more like our linear equations. And this is clearly exponential when it increases by 1% each year. And this one down here is just weird. Not rebalance. Why would I add 50 to the 500? I don't know. So I'm gonna go with those are the only 2 viable options. Does that make sense? Okay. Any other questions from any practice to get by? Or study guide if you're already in that. Yes? One on lesson 17. Okay, so population of the city in 2010 is 50,000 and grows by 5% each year after. Which of the following is a true statement? Select all that apply. A function f, which models the population of the city, t years after 2010, would be this. So let's see. It's definitely an exponential function. This isn't an exponential function format. So let's see if it's right. Does it have the correct initial amount? Okay, and it says that this is growing by 5%. Would a B value of 0.05 be growing? It would not be, and if you graphed it, you would definitely see that that's decay, because that B value is smaller than one. It looks like they forgot to add it to the one. So that's incorrect. Between 2010 and 2020, the population grows by a factor of about 0.6. So factors, remember, are equivalent to like what your B is, that's what you'd be multiplying by each time. In exponential functions, your factor does not change. So forget the part that says between 2010 and 2020. Let's just see if our factor would be 0.6, which if I do 1 plus 5% as a decimal, what is 5% as a decimal? My growth factor should be 1.05 then. So not this one. I would also say 1.6 is not equivalent to 1.05, so I did not do that one. We'll see if I'm wrong, but say it. The population of the city in 2017 is about this much, and then it has other values that we have to put in our calculator. So let's make our expression. Our initial amount was 50,000. Our growth factor would be 1.05. And remember, T is years since 2010. So how many years since 2010 is 2017? So T should be 7 when we're checking this one. How many years since 2010 is 2020? 10 for that one. And for this one, how much, what should T be? Because Desmos will kind of look weird if I split screen right now with all my writing, I'll look it up on my phone. But if you're getting something different than what I'm getting, just make sure you screw it up. So we have 50,000. 1.05 to the 7th power. Are you getting an amount that's pretty close to that? 70,355. So I would pick that one. When I change the exponent to 10, would you say it's pretty close to 81,444? Yes. And when you change the exponent to 20, would you say it's about 132,664? Yeah. Okay, so let's see what the key says. Says I should pick one of these. I disagree, so let me see if that's an error on the key real quick. It'll take time to rescore, but it should have just been the 3 we said, not, it wasn't close enough to me to 1.6 when it's 1.05 for the growth factor. All right, any other questions? Anything so far?